Hi, welcome back to this video series for Always On. In this particular video, we'll be enabling the Always On feature from SQL Server Configuration Manager and also understand availability modes. Let's have a look at some of the things I already identified for this session. So first of all, we'll enable Always On all participating servers. I beg your pardon. We will create login for the service account on both servers. So in our case, we have just 2 servers in our topology. So if you have more, then you have to do this on all the servers. We'll create a database and we'll spend more time understanding the availability modes in Always On. So this is a concept that's quite confusing for a lot of people coming into this world for the first time. All right, so let's get to it. So I'm going to go into secondary. So first of all, we want to enable the Always On feature. If we try to connect to this server, you'll notice that there is a node here that says Always On high availability. If you click on that, you're going to get this error saying the Always On feature must be enabled for the instance, for the server instance. So for each of the server instances, you have to first enable the feature. And where do we do that? We do that from the configuration manager. And I like to spend a little bit of time just to show you around the configuration manager as well, not just enabling the Always On feature. So if you would be wondering already that how did I get here? For those who don't know already, you can go to the Windows menu. So there are 2 things you can do. You can either search for configuration. By the time you type in configuration already, you have a couple of options. What you're looking for is SQL Server 2016 or 2014, depending on the edition that you have installed, and then you see configuration manager. If you click on that, it will bring it up. The other option is if you click on the arrow down, you'll see some of the tools or softwares that you've installed. So you can search by name or date installed, category, most used. So if you put date installed, for example, you can see that part of the latest softwares that's just been installed today. You can see I installed a couple of services here, right? All right, so because I have it already, I don't need to open it. So the first thing I want to show you is services. So the SQL Server engine runs as a service. On your Windows operating system, there are so many services that are running. And there is actually a tool that can show you all the different services that are running on your Windows. So if you go into run, for example, and you type in services.msc and hit OK, you have a little software that opens up and shows you all the different services that are actually running. You can see things that are related to SQL and things that are not related to SQL. Everything. You can see Hyper-V, network related services. So if we're looking for SQL Server, for example, you can just type in SQ. Yeah. So on my keyboard, I've just typed. So if you type, let's say I type N, for example, it takes me to all the services that start with N. So if I put in SQ type together, you can see that I have SQL Server service running here, and you can see the status here says it's running. So you can pretty much do the same thing we're about to do here, right here, which is, for example, if you want to stop the service, pause, restart, go to the properties, you can see you can do quite a bit of things. But Microsoft has decided to give us this tool so that things like this that are specific to SQL Server can actually be contained within the configuration manager. And Microsoft also highly recommend not to use the services tool for SQL Server related services configuration or network related configuration, you should rather use the configuration manager. So if I were to stop the service, for example, I wouldn't do it on in the services tool. I'll rather come here to do that. So what we actually want to do is to enable the always on feature, which can actually be gotten from the properties of the service. So the installation we currently have is just one, so we have just one installation of SQL Server. That's why you're seeing this here. If we had more, you see each of them running as separate services. So if I go into properties, you would see there is an option here that's called always on high availability. If I go into the properties for the SQL Server services from the services.msc, you notice that we don't have the always on availability option here. So bear that in mind. So if you go into the always on here, you'll see this button here that says enable always on availability groups. And that's all you need basically. So if I hit on apply and okay, so that literally the option there says we have to restart. So I need to now come here and do the restart. So I'm going to close this. So this is just a way of letting you know that this exists in case you need to do some work that are non-SQL Server related in the services section. All right, so if we go back into here and refresh and hit on the always on high availability, now we don't have that error, and you can literally pretty much click on the note. We don't have any availability groups configured, so but we'll go into that in a minute. So that's this part that's been sorted out. The next thing I want us to do is to create login for service accounts on both servers. So in our case, there are a couple of options here regarding service accounts. In some organizations, you will find them using just one service account running for each of the instances of the availability group replicas. In some other organizations, you have separate accounts running for each installation. So it depends on how secure you want the environment to be. If you really want a secure environment, you would use separate account for each, so that if one gets compromised, it doesn't really affect your entire infrastructure as far as SQL is concerned. So bear that in mind as well. In our own case, we've used separate service accounts for our installation. So I'm on the primary instance right now, and what I want to do is I want to connect. If I connect right now as primary, you can see I'm now connected to the primary instance. If I now want to connect to the secondary and hit connect from primary, I'm going to get this login field for primary SQL admin, and the reason is because the login for this service account does not exist on the secondary on the primary instance. So no, I beg your pardon, on the secondary, because we're trying to connect to the secondary, so we don't have these primary underscore SQL admin service account existing on the secondary. All right, so what we need to do then is basically create that. So to do that, let's go into security. Let's go into logins. So as you can see, we're now in secondary, but we only have secondary SQL admin existing here in the login. So the service account for primary cannot come into this server just because it doesn't exist here. So what we need to do is to create that. So to do that, you have to right click, go to new login, and what you need to do, what we're interested in is Windows authentication, because don't forget that the service account is running as a Windows account. It is not a SQL Server authentication. So it's a Windows account that does not require password to log in. All right, okay, so what we need to do is let's do a quick search for that, and we want to search for primary. let's see from where it's going to search. It's going to search from users. So let's ensure that users is selected. Whether you select this or not, it doesn't really matter. It's actually going to search here. And if I check, okay, it didn't find it there. That's because we need to tell it where to search. So apart from telling it that it has to search from users, we have to tell it from where it's going to search in terms of the whether from the entire directory or from the computer. We know that primary underscore SQL admin does not exist on the secondary computer. Rather, it exists in the active directory, which the domain controller is basically hosting. So it's going to search from users in this exploit.internal domain controller active directory. So if you hit on that, and now if we check, you can see that we found that. Hit OK, and that's good to go. So what we're going to do is we also need to specify the server roles. So these server roles basically determines what sorts of things that it can do. Now, if you give it sysadmin, what you're basically saying is it can do anything on the server. It can create, delete, modify anything on the entire instance. But if you want the permissions to be more granular, you can give it maybe setup admin, server admin, security admin. So security admin, for example, can only do things that are related to security. Disk admin, DB creator, database creator means it can only create database. Bulk admin, it can only do bulk related activities. So, I mean, these are just granular permissions that you can grant a specific user or login. In this case, this is a login because a user is different from login as far as SQL Server is concerned. So I'll also explain to you the user bit of it, but this is login we're talking about now, because user is specific to database, but login is specific to instance, the entire server, SQL server installation, right? Okay, so we're going to give it sysadmin because we want it to be able to do everything, and you can ignore all the other ones. So these are the two things, general and server roles, that we're interested in. And we can default the database to master. If you wanted to do something otherwise, that's fine, but we actually haven't created any database here, but it's fine to default it to master. And that's it, really. So if we click on OK, you can see that the login now exists on secondary. If we go back to primary and now try to log on to secondary from primary, now it's able to get access, and that's good to go. So basically we can do this. So we should be able to do the other do it the other way around. So on secondary we need to create this this is secondary. All right, so on primary rather, so on primary we should also create, let me disconnect the secondary so it doesn't confuse you. So on primary, now what we need to do is create secondary here as well. So create a new login and let us search. Let's search from the entire directory. Let's search for secondary, and that's found. Let's give it the sysadmin server role, and that's also happy. So that if we go into secondary, we will be able to connect to primary, and that's good. So from regardless of where we're connecting from, so you can see we have two remote desktops open. This is primary here. We can basically connect to secondary. We have both connection established, and we have both established here as well. So that's the purpose of this that we have just satisfied. So the next thing we want to do is to create a database. So this is something that we are familiar with already, so we can easily do that by right clicking, and we can say always on availability group db AO always on availability group underscore db. Okay, that's fine, and we can leave all the default, leave everything at the default, because we're not following best practices here. We have done that in standalone installation that we did before. So if you need to consider a lot of things for best practices in terms of configuration for database creation, we've done that. We've treated that in other videos where you want to determine the initial size, the growth, auto growth settings, and things like that. So we're not really concerned about all that here. So what we're intending to demonstrate is always on. So now we have a database created. All right, so we're just taking everything step at a time. Now here's where we're going to spend a couple of time, which is to understand availability modes in always on. To actually crack our understanding of this concept, what I'd like you to do is, first of all, go to Google and type in always on availability mode. The very first page that comes up, just click on it and you'll see this documentation here. If you scroll down, you'll see that there's quite a lot of information here, which if you start reading it for the first time, I bet you it's going to be very, very confusing for you, and you'll probably be turned off, by understanding all the things that have been explained there. So if you have time later on after this particular video, you can come back here to read everything and try to read all the different articles that's been written beside. That will give you a lot more understanding about what this technology is all about. But what I've decided to do is to summarize everything in just these 5 to 6 steps. But of course, I'm going to also explain in words, and I would also do a little paint demonstration just to explain certain concepts of what's going on. And ultimately, I've done a little summarize. I've summarized some of the things that we're going to talk about also in this last slide. But let's get started. So what do we mean by availability modes in always on availability groups? Now, this is a property that determines the failover behavior of our setup. So we have our availability group set up, but what determines if it's going to be an automatic failover or if it's going to be a manual failover? So this is one of the core concepts that this property determines. So when you configure your setup, how do you know if there's going to be an automatic failover or there's going to be a manual failover? Well, basically there are 2 modes. So the first mode is asynchronous commit mode, right here. Don't be thrown off by the big English. And here is the other one, which is synchronous commit mode. And what a synchronous commit mode gives us manual failover. There's a lot more to these. I will explain that in detail, but on a very high level, just understand that asynchronous commit mode gives manual failover. And on a very high level as well, synchronous commit mode gives automatic failover. But note, it also gives manual failover, but it's basically a combination of both automatic and manual failover. Sorry about that. Manual failover as well. But asynchronous commit mode cannot give automatic failover. So this is going to lead us to another question and say, how does all this play out? What does it mean? How do I know when to implement asynchronous or synchronous? All right, let's quickly have a little bit of demonstration with this. So what I'm going to do is let me get a brush to use, and I'm just going to demonstrate our setup a little bit. All right, so let's say this is our environment right here. Okay. All right, so this is our data center, and we have one server there, we have another server here. Currently, this is what we have, which is the primary and the secondary servers, but let me explain it with 3 setup. So we have one primary, so this is our primary, and this is secondary 1, and this is secondary 2. Okay, so what we have is, let's say you understand already that in always on or in database mirroring, what happens is the transaction log gets shipped from the primary to the secondary, and always on is like an advanced database mirroring technology. So we have let me get another color to show the transaction log. So we have a transaction log here from the primary. We also have a transaction log on both of the secondaries. All right. What happens is we have transaction log that gets shipped across here, and we also have the same thing that gets shipped across. Okay, what if we decide and say that the secondary 1 server is going to be configured as the synchronous commit in the synchronous commit mode. So actually, let me use a different color. Synchronous commit, and this is going to be in a synchronous commit. So what that means is, of course, remember we can have automatic failover here, and here we can have manual. And what I mean by automatic is, if something happens to the primary server without any manual intervention, there can be an automatic switch whereby the secondary 1 instance becomes the active primary while the old primary is down. But in the case of secondary 2, there cannot be an automatic failover, and what basically happens is someone will have to manually click something to initiate that failover. And here is what's going on with the synchronous commit. What happens is, whenever the transaction log is shipped across, so let's say you issue a transaction on the primary, and you say begin tran. Okay, you issue a begin tran, and you have some code running. There's some code, and you say commit tran. Now what happens is, this commit does not get committed on the primary until it has been committed on the secondary 1, because it is configured for synchronous commit. So what happens is secondary 1 gives an acknowledgement to primary 1 after it has received its own portion of this transaction. So this transaction is actually being run on the primary, but in the transaction log, the primary sends that transaction over to secondary 1, and secondary 1 receives it and then sends an acknowledgement back to primary and says, hey, I've got that transaction. Now you can commit to your transaction log. And this concept is called hardening. So the transaction becomes hardened in the secondary 1 transaction log first before it gets committed on the primary's transaction log. And this ensures that there is high level of synchronization between primary and secondary 1. So you would always see something like synchronized. And you're going to see this by the time we implement always on databases. So between the primary and the synchronous commit configured secondary, you would always see both of them will always be in a synchronized state. And of course, if you think about it, there will be some level of performance here because for this guy right here, which is running the code. So this is Dari, for example, and Dari is running this transaction. That means Dari would have to wait for a couple of, well, it's depending on the size of your transaction. It might actually be a negligible latency we're talking about here, but sometimes it's very considerable, and that's because there has to be some level of acknowledgement going on between the primary and the secondary 1 instance. So the performance for these configuration is actually low. It's not high performance. But if you think about it, the fact that they're both synchronized means you are never going to have anything like data loss. So whenever there is need to failover between both servers, you are sure, 100% sure that whatever data existed on primary, you would find it on secondary. So it is just a game of performance against high availability, performance against data loss. So there is no possible data loss, but the performance is not that great. Now, shifting our focus to secondary 2, which is configured in asynchronous commit mode. It's exact opposite of what we're talking about in the sense that it's got better performance, but there's possible data loss. And that's because whenever the transaction log is being sent across to this server, it doesn't send an acknowledgement back. You issue begin tran, you commit it right away, it goes into the primary transaction log and sends it over to the secondary and forget about it. It doesn't care whether it got there or not. So there's possibility of data loss in between. That's possible, but it doesn't care. In the case of synchronous commit, if there are any issues on the secondary, it never commits on the primary. So that, it does not give you that data loss thing. You're sure that your data is always going to be in synchronized state. But in the case of asynchronous commit mode, it doesn't care. It just sends across the transaction log and forgets about it and moves on. So the performance is great. Instantly you hit commit tran, it commits straight away, right? But what happens is you cannot have automatic failover. So it has to be a manual failover. Whenever there is a failover, maybe something happened to your primary, it goes down, for example, and you have to do a manual failover. If certain transactions that were committed on primary before it went down could not make it over to the secondary that is configured as asynchronous, that transaction is lost and gone. So by the time this becomes your primary, there is chances that some of the transactions that did not make it over here will not exist here. So these is basically what the availability mode is all about. Of course, if you go into the documentation that I showed you just now, there's a whole lot of information that's going on here, but on a very high level, this is typically what's going on. And they have actually, Microsoft has actually given you a typical architecture here with 5 different nodes. As you can see, each of these nodes belong to a Windows Server failover cluster. And now we have availability group layer on top of it. And you can see synchronous commit with automatic failover, asynchronous commit with only manual failover, and asynchronous commit with only forced manual failover. So like I said, synchronous commit can give you both automatic and manual failover. So you can have a primary replica, a secondary replica that is automatic failover, another secondary replica in synchronous. Both of them are in synchronous, but this is manual failover, and then these two are asynchronous, and you can only force manual failover to them. But if you take notice, most of the time the servers that are configured in asynchronous mode are not close to the primary instance. So because of the latency that has to go through, it's always better off to configure the server that is close to the primary in synchronous. So for example, if the primary is in Europe and one of the secondary is in America, for example, it is not advisable to configure these in synchronous commit mode, right? Because it's going to take a while to travel all the way to America, and then these will have to send acknowledgement back, and that, depending on the strength of the network, if the network is not that strong, then there's going to be a whole bunch of bottleneck going on, and your queries will take a long time before it gets committed. But if both of them are located in Europe, the speed, you gain advantage of the geographical location, and the speed is going to be better off. Even if you have slow network, the fact that they're close to each other, it improves the performance in that wise. And the whole communication in terms of the acknowledgement will be there, but it's going to be better off than having the servers far away from each other. So this is a typical architecture. You can have a read through all of these, but what we've just discussed is basically what this is all about. What I've also done is just had a brief highlights of all the things that we've talked about to summarize and have you understand the concept even better. So in asynchronous mode, what you can have is forced and manual failover. The performance is better because the secondary does not send acknowledgement back to the primary before the primary commits the transaction to its own transaction log. And this is traded against high availability and possible data loss. So there can be possible data loss, and you may not have high availability in this instance because the data can be lost in the process. And again, it will always remain unsynchronized. So you see that status when we go into the configuration itself. The status will always remain unsynchronized because yes, it will not be synchronized, right? And in synchronous mode, rather, not synchronized, synchronous, you can see that the state is going to be always synchronized, although there are certain instances where you would see the status showing unsynchronized or resolving. So these are certain times where, for example, the secondary is unable to catch up with the transaction, or there's some little glitch going on in between, and there's a timeout. So what happens basically is, let me go back into this paint. What happens is, whenever the primary is trying to send transaction, and for some reason, maybe for network issues, it's unable, or something going on the secondary, that it's unable to apply the data to its own transaction log. While the primary is waiting, there's a timeout setting. So if the timeout setting says wait for a maximum of 1 minute, now after 1 minute, the secondary instance is still unable to commit to its own transaction log. What happens is the mode changes by itself from synchronous to asynchronous, because it is unable to commit that transaction to its own transaction log. And at that point, this synchronized state is going to change. You wouldn't see synchronized change status there, and it will either be in resolving or it will be in unsynchronized status at that point. But what happens is, as soon as the problem is fixed on secondary and it's able to catch up with all the transaction logs, it will handle it by itself and switch back into synchronous mode. And at that point, when all the transactions are nicely applied to secondary and it's up to date with the primary, it's going to change itself back to the synchronized status. But that kind of thing does not happen in a configuration where the setup is asynchronous mode. So bear that in mind. Take note of all these highlights. If possible, rewind the video, listen to everything we've talked about again, take your own notes, and also read this documentation from the beginning to the end, so that you can have an ample understanding of going on with always on availability. So this is where we're going to end this particular video. In the next video, we will now implement always on availability group, such that we have created our database. We'll put some data into that database, and then we will see what's going on. We'll try to failover, we'll test a couple of things, and then we'll understand a lot more about what this whole always on availability group is all about. Thanks for listening, and I'll see you in the next video.